Hello there. In the earlier videos, we started explaining how the DX system works from the heat transfer and the thermodynamics point of view. The links to those videos are given below in the description. Well, now, we will go more in depth into each component of the AC system, and start with the compressor. As we already know by now, the AC system is a closed loop of mainly 4 components: the compressor, 2 heat exchangers, and the expansion valve circulating refrigerant. These components shall be covered one by one in our upcoming videos. To start with, this video will be focusing on the compressor. The compressor is the source of pressure in the AC system. It pumps the refrigerant throughout the cycle, just as the heart pumps blood into the human body. This pressure is vital for the refrigerant to be compressed and moved to the condenser side. Though the role of the compressor is the same in all AC systems, there are mainly 2 different categories of compressors, used depending on the compression mechanism: the reciprocating and the rotary. The rotary compressor can be the screw, scroll, centrifugal, or the vane type. To start with, the reciprocating type is a piston cylinder design with 2 valves, suction and discharge. The piston's back and forth movement creates high-pressure compression. This type is mainly used in residential to light commercial AC system applications. The screw-type compressor is composed of 2 helical screw-like rotors that move the air from the low-pressure end to discharge it at the high-pressure end. This type is mainly used for chillers of big buildings with large cooling spaces. Then the scroll type is composed of 2 scrolls, one is fixed at the center and the other is moving, and eventually compressing the gas in between. This is commonly used in residential to commercial applications. The centrifugal type uses centrifugal force to suck in the refrigerant gas. With the help of an impeller, the gas gets compressed. This is used for chillers cooling large spaces, even bigger than spaces that use screw compressors. And finally, the vane type is composed of a specially designed rotor that rotates and compresses the air that gets trapped in between. This type is used in residential to commercial applications. The vane compressor is further classified as single or dual rotary vanes. Generally, compressors are of 2 types, depending on the driving mechanism: the fixed speed and the variable speed type. The fixed speed type, as the name implies, rotates at a constant speed during operation. However, the variable speed type, which is also known as the inverter type, rotates at different speeds, depending on the energy input to the compressor. The compressor is electrically driven by an inbuilt motor, and the electrical energy input is what determines the speed and output of the compressor. This motor is what permits changing the compressor speed, as per the cooling or heating demand. Despite the type of the compressor, or the compression technique, the application is what decides which compressor to be used. And by this, we come to the end of our session. In the upcoming video, we will elaborate more on heat exchanger types, working principle, and much more. Thank you for listening, and don't forget to like our video and subscribe to our channel to stay updated with our latest videos.